The last review, final exam review number 5. It's going over some quadratic stuff. We don't need the quadratic formula a whole lot in this class, but there it is. If you need to solve for a quadratic formula, we'll go over it in a couple of problems. But first, let's start with an absolute value inequality, just out of the blue. How do we solve those again? Let me show you. So first thing you're going to do is you're going to get the absolute value isolated. So you got the absolute value of x minus 9 is greater than 9. Now you can do this, to do this by hand, you have absolute value of x minus 9 is greater than 9. I like to do x minus 9 is greater than 9. And then I say, and I flip it, so I would do x minus 9 is less than negative 9. So we write two fraction inequalities, one with the regular and one with flipping it and changing the sign. Then you solve. So you add 9. So x is greater than 18. Add 9. X is less than 0. So x is greater than 18, or x is less than 0. That's going to be A. Let me show you how to back it up with a graph. So if I want to graph that, you can do shift the button above enter for the absolute value of x plus 9, x minus 9, excuse me. And then you could say, heck, you can do greater than 11. And you can see right here how it's shaded, right? So if you look down here, everything above 18 to the right of it is shaded, and everything less than 0 is shaded. So all your solutions are basically going the opposite direction. So on a number line, it looks like this. (19, 20, 21), those work. (-1, -2, -3), those work. But anything between 0 and 18, including them, do not work. All right, here is a quadratic equation. Let's just go ahead and review quadratic formula in case you ever need it. First, get everything equal to 0. Second, plug in to the formula. So opposite of B, A is 5, B is 7, C is 6. So we say -7 plus or minus the square root of B squared, so 7 squared, minus 4 times 5 times 6, all divided by 2A, so 2 times 5. So you'll notice that it's going to have a -7, and that's going to become 10. We do have to figure out what 7 squared minus 4 times 5 times 6 is. And we can do all that in the calculator. Leave the square root out of it. And that gives you -71. So -7 plus or minus the square root of -71 over 10. Now you might remember that if you have a negative, that's actually an I. So it's an imaginary number, -7 plus or minus I squared of 71 over 10. So anytime you have a negative in the square root, you got to pull an I out. You'll shoot your eye out. That's how you do that one. And that's how you do number 3 as well. So 3x squared plus 5x plus 3 equals 0. Negative B, -5 plus or minus square root of 5 squared minus 4 times 3 times 3, all over 2 times 3. So you'll have a -5 and a 6. And it looks like these are the same answers. So let's see, 5 squared is 25 minus 4 times 3 times 3. 9 times 4 is 36. 25 minus 36 should be -11. So that is -11. So -5 plus or minus the square root of -11 over 6. Again, just like the previous problem, if you see a negative, pull the I out. And well, these are both the same, so either one of those is fine. All right, part 2 is going over exponentials and logs. You can see some of the rules here, but we're going to get right into it, and I'll refer back to those as we need to. So how do you solve a log equation? Let's start with number 1. Approximate solution 2 times 3 to the negative 4x equals 20. So one way to do any equation is to use Desmos. Now in the parentheses, you'll have to put negative 4x, and then the second line will be y equals 20. And you can solve that just by seeing where they intersect. So that's going to give you negative 0.524. Now here's how you do it the right way. First, you're going to isolate the base by dividing by 2. So that's going to be 10. 3 to the negative 4x equals 10. If you remember, you're going to do this as a log. So you do log base 3 of 10 equals negative 4x. So you write the base of the exponent as the base of the log. The other side is what's in the parentheses. Set it equal to your exponent. So you bring that out to the end. So you can get that in your calculator. On Desmos, you'll type log underscore 3 right arrow 10. So again, do the underscore for the base, and that becomes 2.0959. So approximately 2.0959 equals negative 4x. And then you can divide by negative 4. So that number divided by negative 4 is negative 0.5239. So x is negative 0.5239. Of course, that closest number here is there. All right, let's talk about interest rate. We've done these before as well. So the function a times 1.2 to the t power models the value of an investment after t years based on the function what's the approximate monthly rate. So let's recall on what you want to do. You're going to take your 1.2. Remember, this is in years. So if you convert 1.20 to the 1/12th power, think of your time as months. If you have 12 months, 12 months times 1 over 12, that'll cancel out as a year. But then you can figure out what that base is as a monthly. So you do 1.2 to the 1/12th power, and that'll give you your monthly base. So that becomes 1.0153. So now what we do is we say a times 1.0153 to the m power. That's your monthly equation. And it says what's the rate? So the rate, this is, remember, 1 plus the rate. So if you subtract 1 from this, that'll get you your rate as a decimal. So 1.0153 minus 1 is about 0.0153. As a percentage, that is 1.53%. So we take that 1.0153 and we multiply that by 100. That is 1.53%. So the closest percent we have is 1.5% right there. 1.53%. Okay, number 3, determine which of the following exponential functions are increasing. So we have a few of them here. If they start with a negative, it's going to be decreasing. So that's decreasing, that's decreasing. That makes it easy. So which one of these are increasing? Well, let's check them out. So we have 2 parentheses 0.25 to the x power. That's decay. So that's decay, that's going down. So let's look at 4e to the x. E is just the number. So 4e raised to the x power, that's growth. So this is the only one that's increasing as it goes up. Question number 4, given the exponential equation, y equals 7 to the x plus 5 represents the population after 2005, with x as the number of years since 2005. What's the population in 2008? Well, how many years has that been since 2005? That's 3 years. So x is going to be 3. So 7 to the 3 plus 5, 7 to the 8th power. So one of those is 7 to the 8th power. Okay, down here goes over the end behavior rules. So we'll graph those and we'll talk about them. And points of discontinuity as well. So let's get into those. So which function has a point of discontinuity at x equals 3 when graphed? So discontinuity, you can't divide by 0. So if I plug in a number to either one of these, since these have fractions, if I plug in 3, that's 3 minus 3 over 9, which is 0 over 9. That's valid, you get 0. That's not a point of discontinuity, but if I plug in 3 here, that's going to be 5 over 9 minus 9, which is 5 divided by 0. So it's not possible, right? Can't divide by 0. So if you graph that, it'll look like an asymptote. It'll be x plus 2 over x squared minus 9. And you can see right there, there's actually, it's got 2 points of discontinuity, but see right at 3, it's not gonna show you any values there, right? X equals 3 is a vertical asymptote. So it's a vertical asymptote. So can't divide by 3 because you 0 on the bottom. That's going to be your answer. Let's talk about end behavior now. Honestly, just graph this. So let's graph that function. We say x to the 3rd power plus 3x squared plus 4x plus 1. And the question wants to know what is the right end behavior. So right end behavior is always as x goes to infinity. That's right. So on the graph, since this graph opens upward, then the y value, the f of x value, will also go to infinity. That's up and right. So you want, since that goes upward, right and up, the f of x will go to positive infinity. So right, up. All right, number 3, what's the left end behavior? This graph here goes down on both sides. So the left end behavior is going to be as x goes to negative infinity. So it's going to be one of these two. Since it's pointing down, that means the y value is going to go to negative infinity. So it's going to be down. So it's left and down. This would be left and up. Left and down is what we're looking for. All right, the last part's Unit 9, statistics. We actually don't need normal curve stuff, but it does talk about types of studies and stuff like that. So we're just going to get into that. And we'll do what we can, okay? Basically, we want to talk about sampling and population. Please take AP Stats next year, by the way. I teach it. So number one, a reporter wants to know the percentage of voters in the state who support building a new highway. What's the reporter's population? So let's think about population is what you want to sample from. Percentage of voters in the state who support building a new highway. So in this problem, we would say the number of people who live in the state? No, because not everybody's a voter. Number of people who were interviewed in the state? No, that's the sample. All voters over 25 years old in the state, doesn't say anything about age, but all eligible voters in the state would be your population. So the sample is this one, the population is that. A student wants to determine the most liked professor at college. Which type of study would be the most practical to obtain this information? A simulation, that's when you try probabilities to see what works. An experiment, you try to determine cause and effect. A survey is when you ask for opinions. An observation is when you just look at data. And since we want to know a question, we conduct a survey. What method would Josh use to determine if a new treatment for baldness is effective? With treatments, we want to see if something works. So we want to determine cause and effect. So we do an experiment to determine if something works. Number 4, a principal wants to survey 150 students to determine which electives to offer during the next school year. There are 1,800 students in the school. Which procedure could the principal use to select a sample using a systematic random sample? Systematic random samples are patterns for like every 3rd person, every 5th person, every 10th person, etc. So attain a list of all students, start with the 8th student, select every 12th student until 150 students have been selected. That's every 12 students. So that would be your answer. Number 5, a town has 685 households. The number of people per household is normally distributed with a mean of 3.67. Just go ahead and skip that. We don't need that. But if you're interested, take AP Stats. I'll be happy to teach you that. Go over all the normal stuff. So that's it. That's review number 5. Thank you for watching.